Rational functions, simplifying and multiplying and dividing. Okay, for today we're going to focus just on simplifying rational functions. So for this first example, we have 3x squared over 12x. You should first focus on the coefficients here. So we need to simplify 3 over 12. So I'm trying to think of a number that divides both 3 and 12, and that would be 3. So if I divide 3 by 3, I get 1, and if I divide 12 by 3, I get 4. Next, I'm focusing on my variables. I only have an x here, so I'm going to look at my x's. I have x squared over x to the first. Recall that our exponent rule, whenever we're dividing common bases, x and x, is to subtract. So I'm going to take my larger exponent minus my smaller exponent. 2 minus 1 is just 1, so it becomes x to the first up top. I always put my x where I had more x's to start with, and since this 2 is bigger, I know I'm going to put my x on the top of the fraction. I'm just going to rewrite my problem now, or my answer. It's just going to be x over 4. There's no need to put that 1 out front. Okay, so same idea, but now we have some y's and a z in here. So we're going to start with our coefficients, our -6 and our 12, or -16 and 12. Again, I'm thinking of what number divides both -16 and 12, and that would be 4. So I'm going to divide -16 by 4, I get -4. Divide 12 by 4, I get 3. Now I'm looking at my x's. I have x to the second over x to the fifth. I'm going to take my largest exponent, which is 5, subtract my smaller exponent, I get 3. So it's x to the third on the bottom. Again, I'm putting my x on the bottom because there were more x's to begin with. There were 5 of them on the bottom as opposed to 2 on the top. For my y's, I'm going to do 7 minus 3, my larger exponent, minus my smaller exponent, and I get y to the fourth on the top. It's going on the top because there were more y's. I don't have another z to combine with my z, so I'm just going to leave z to the fourth where it is. This is my final answer. Okay, so now you'll notice that this problem is different than the previous two because there's adding or subtracting going on. So here we're going to factor. So I'm just going to look at the top and I'm going to factor this. Since it's just a binomial and there's no x squared, I know I can just pull out a common factor. So I'm trying to think of what's common between 3 and 12. Well, 3 is. So if I pull a 3 out, I get x minus 4. On the bottom, same idea. What's common between 3x squared and 12x? Well, I can pull a 3x out this time. Notice how both of the terms have an x in them. And I have x minus 4. Okay, if you notice in my problem now, I've got common things on the top and the bottom. So the 3's, I can cancel out the 3 since I have one on the top and the bottom. Same thing with the x minus 4. Now I had to cancel out that entire parentheses, x minus 4, on top and bottom. The only thing I have left is this little x right here. So my answer is 1 over x. Okay, again, we have to factor, and now it's a trinomial. There's 3 terms, so I'm going to factor by figuring out what multiplies to my third term and adds to my second term. So what multiplies to positive 6 and adds to negative 5. If I write out my factors of 6, I have 1 times 6 and 2 times 3. Well, any of those could actually add to negative 5. I just have to put my negatives in the right spot. So if I was going to use 1 and 6, it'd have to be a negative 6. But do these multiply to give me a positive 6 still? No, they don't. So now I'm looking at my 2 and 3. I could make both 2 and 3 negative. That would add up to a negative 5. But does it multiply to a positive 6? Well, it does, so those are going to be my terms. My factors, I'm sorry. So x minus 2 and then x minus 3. For the bottom quadratic, I'm looking to multiply to negative 15 and add to 2. My factors of 15 are 1 and 15 and 3 and 5. 1 and 15 definitely can't add to 2. 3 and 5 added to if I make my 3 negative. So I have x minus 3 and then x plus 5. Again, I'm looking on the top and the bottom for something that's in common, and the x minus 3 is in common. So I'm going to cancel it out of the top and the bottom. And my final answer is just x minus 2 over x plus 5. Now, some of you might fall into this trap of thinking, oh, but there's an x on the top and on the bottom, so I can just cancel out the x's and make it negative 2 over 5. But that's not the case. You would have to cancel out that whole term, x minus 2, or that whole term, x plus 5, but we can't here. So don't just cross off the x's because you see one on the top and the bottom, because they're attached to something by addition or subtraction. Okay, jump to the end of your notes where it says application teacher talk, and I'm going to have you do these two problems on your own and then check back with the video to see what the answers were. So pause your video now. Okay, for the first problem, I divided 12 and 9 by 3, so I got 4 over 3. My x's canceled out because I had the same thing on the top and the bottom. 2 minus 2 is just 0, so they canceled out, and my y's left on the bottom. For the second problem, my factors for the top quadratic were negative 4 and negative 1. And then for the bottom, I just pulled an x out because it was a binomial, so I'm looking for a greatest common factor there. Then I had a factor of x minus 4 on the top and the bottom. I canceled them out, and I was left with x minus 1 over x. Again, do not cancel out these two x's at the end. That top x has a minus 1 attached to it. So if you were going to cancel out that, you'd have to cancel out the whole thing, which we can't here. Okay, pause your video and you will resume at this point tomorrow with the video notes. Okay, today's notes are going to focus on multiplying and dividing fractions. We're going to have to use the tools that we learned yesterday about simplifying rational equations, or expressions, once we get them multiplied or divided. So with this first one, we're going to multiply. Whenever you've got big numbers like this, I like to start by simplifying whatever I can simplify. So I'm looking for something on the top that might simplify with something on the bottom. So I see 25 and 45. I know they both will simplify by a factor of 5. So I'm going to cross those off, and I'm going to divide both of them by 5. So I get 5 over 9. For the 96 and the 38, I know that they at least simplify by a factor of 2 because they're both even. So I'm going to divide them both by 2, and we get 48 over 19. And don't forget the n. And that seems like all the factoring that I can do now. Oh, these actually might simplify more. I believe that I can divide both those by 3. So let's do 48 divided by 3, and we get 16. So you can cancel anything out on the top with anything on the bottom just to simplify this to an easier problem. So now I'm going to multiply straight across. So 16 times 5, I get 80. And then 19 times 3, I get 57. Don't forget the n. Now, you'll want to check, just make sure that there's nothing that simplifies between 80 and 57, and once you plug that in your calculator, you'll see that there isn't. So there's your final answer. Okay, so again, you notice that we have addition and subtraction going on, so we're going to need to factor each of these individually. So I'm going to start with this top left expression, and I can't simplify x plus 7, so I'm going to leave that alone. Below it, we have 7x plus 35, so I'm going to try and pull a GCF out here. My greatest common factor would be 7. For the right side here, I know that x minus 8, it's not going to simplify at all. And then the top part I can factor. So I'm saying what multiplies to negative 40 and adds to negative 3. If I write out my factors of 40, I get 1 times 40, 2 times 20, 3 doesn't go into 40, 4 times 10, 5 times 8, 6 doesn't go into 40, 7 doesn't go into 40, and I'm back up to 8. Okay, so which of these could potentially add to negative 3? Well, not 1 and 40, not 2 and 20, not 4 and 10. So there it is, 5 and 8. I'm going to make my 8 negative so that it adds to a negative 3. So I have x minus 8 and then x plus 5. Something you can do if you're stuck looking for factors, maybe you're like, I don't know what multiplies to 40 and adds to negative 3. Well, you can look down here at all of these other factors that you have. So we've got a negative 8, a positive 5, and a positive 7. Chances are you're going to use at least one of them. And in this case, we had both. Okay, so now we can think of this as one big fraction bar. So just go ahead and attach that on. We're looking to cancel out things on the top with things on the bottom. So here's my first one. I have an x minus 8 and an x minus 8. Those are going to cancel out. I also have an x plus 5 and an x plus 5. Those are going to cancel out. I cannot cancel out my x plus 7 on top with my 7 on the bottom. Okay, again, you cannot cancel out this 7 because it's attached to something by addition. So that's just my final answer. Alright, so now we're going to work on division. The way that we divide fractions is we use a mnemonic called KFC, so Kentucky Fried Chicken, KFC. There's a spot at the beginning of your notes that you can write this if you need space to write this. So K stands for keep, so we're going to keep the first fraction the same. The F stands for flip. We're going to flip the second fraction. And the C stands for change. We're going to change our sign from division to multiplication. So here we go. Keep the first one. Flip the second one. And then change your sign to multiply. So now it's just like multiplying them. We're going to start by factoring anything that we can. N plus 5, we can't pull out a GCF or anything, so we're just done with that. 10, same thing. N plus 6, same thing. But 3n plus 18, I can pull out a greatest common factor here. So I can pull out a factor of 3, and I get n plus 6. So now I'm looking on the top and the bottom to cancel things out. N plus 6 cancel. We need to check our 3 and our 10. Are there any factors that we can divide both 3 and 10 by? There's not, so we're just going to leave the 3 and the 10 there. So this is what your final answer is going to look like. We're going to put the 3 first. Then in parentheses, we're going to put the n plus 5 over 10. Okay, so again, we're going to keep flip change. So we're going to keep the first one, but I'm going to go ahead and factor it here. So I'm figuring out what multiplies to 54 and adds to negative 15. Well, that would be x minus 6 and x minus 9. On the bottom, same thing. We're going to figure out what multiplies to 48 and adds to negative 14. That would be negative 6 and negative 8. Okay, so I kept the first one. I'm going to flip the second one and change to multiply. Okay, here we go. So now we're looking for common factors. On the top and bottom, I have an x minus 8, so I'm going to cancel those out. I also have an x minus 6. So I'm left with x minus 9 on top, and on the bottom I had a 1. I don't want to leave my answer over 1, so my answer is just x minus 9. Okay, pause your video and try the 2 independent practice problems that have you multiplying and dividing. Here's my answer for the first problem. And here's my answer for the second problem.